And today we have Professor Chris Gobler. He's with the School of Marine and Atmospheric Sciences, which we call SOMAS at the university. He received his PhD from Stony Brook in the 90s. And he also joined as the director of academic programs at SOMAS in Southampton. He was named the co-director of the New York State Center for Clean Water Technology and became the director in 2018. And he has published more than 200 manuscripts. And he's here to talk to us today about the state of the bays. So Chris, thank you for coming.
Okay, well, thank you for the invitation. It's a pleasure to be here. I can say with confidence that I know how valuable the OLLI program is. Both of my parents have very much enjoyed that program during the past, well, I think almost 2 decades, and or getting on that. And so with all the pleasure they've derived from the program, it's my pleasure to be able to maybe return that a little bit and talk to you today about some of the work that I do at the university. And it's not my first presentation. I believe a few years back I gave a presentation live and in person, if we can all remember those days. But
we'll be getting to that soon too. We'll be doing some in-persons hopefully soon, Chris.
Yeah. We'll do that as well, sure. The presentation today, as you can see, is called State of the Bays 2021, and the subtitle, Welcome to the Anthropocene. And well, I guess I won't go into, I won't give an overview. You'll get the idea, but I'm going to essentially talk about our coastal waters, some of the threats to those coastal waters, and some of the solutions to getting us away from those threats. And I should mention, or I will acknowledge that my lab is located out on the Southampton campus of Stony Brook University, and it's these fine young men and women who get all the work done in my lab, and so I'd like to acknowledge all their hard work. They're literally the boots on the ground and the fins in the water that make it all happen. And if you like,
need to do a screen share.
You like what you, what's that?
Screen share.
Elizabeth, can you see my screen?
Well, I'm saying.
Can everybody see? Can everybody see it?
Yes.
Yes.
Yeah. Yes, we can see it.
Fine.
Yes, we're fine.
Okay, good. Great. And anyway, if you like what you're hearing today, you can follow along with what we do and get updates on social media. We're on all the major social media platforms as shown here. So I'm going to start with an overview of a very important concept, and that is the idea of the watershed. And it's an easy one to not think about, but it really couldn't be more central to the existence of life on an island, and specifically life on Long Island. And again, the concept is very, very easy. And the idea is that all of the water that falls onto the land on Long Island enters the aquifer. And as it does that, it becomes our, firstly, our drinking water source. And then whatever is not used for drinking water is discharged into surface waters. And therefore, any activity on land that might alter the quality and the composition of that groundwater will be affecting the water that we drink and our surface waters. And you can see in some of the images here, things to bear in mind, the potential effects of agriculture, the potential effects of surface runoff, and very prominently, as you'll hear later on, the very potentially serious effects of our household septic systems that literally drain into our water supply, but then also discharge into surface waters. And so, as we're all aware, Long Island has changed a lot over the last century or so. You can see the population growth in Suffolk County over the last century. And concurrently, we've seen a tremendous change in the levels of nitrogen, for example, in our groundwater. And that's shown in the figure on the right. And that is over time, those levels continue to rise. And if I was giving this presentation a decade ago, we could all speculate as to what is the root cause. We could say, well, there's more people and that's contributing more nitrogen, and a term might be used like, well, it must be the runoff. But thankfully, there's been some excellent science during the last decade or so. And we now know, it is now clear that the largest source of nitrogen from land into our groundwater and into our surface waters are from what are known as on-site septic systems, because Suffolk County has 70% of its homes not connected to sewage treatment plants, but rather having these sorts of systems that drain into our groundwater. And why fertilizer is also a contributor, it is actually dwarfed by the impact of, as you'll hear later in the presentation, literally hundreds of thousands of septic systems draining into our groundwater. And we know that that nitrogen can exact a very serious effect on our coastal waters. And so this gives you an example of that. Here's some data collected by my laboratory last summer. We begin monitoring coastal waters usually around May, and so we've been doing that this year as well. But this map represents June through September of 2020, just 4 months of monitoring. And in that short period of time, what this map shows is literally dozens of locations with what are known as dead zones. That's low oxygen. I'll talk more about that momentarily. And then outside of the dead zones that are in the blue, you can see all the other colors, by and large, are what we call harmful algal blooms. I'll talk more about those as well. And then also as a consequence, you can see the few yellow spots are places where we've recorded fish kills last year. And this is all happening as not only the nitrogen levels in our groundwater are increasing, but they're also increasing in our surface waters. So in 2020, Suffolk County released a report called the Subwatersheds Plan. And in that report, they demonstrated that, for example, on the North Shore of Long Island, the levels of nitrogen in surface waters have increased by 50% just this century. And on the East End, the surface water levels of total nitrogen in coastal harbors have increased by 50% just this century. And on the South Shore, waters there, the total nitrogen levels have increased by 60%. And again, just this century. So we are living in an era of rapid change. And again, this rising nitrogen has consequences. I mentioned the term harmful algal blooms to give a very brief overview of that. That represents the overgrowth of tiny microalgae. You can see here that can discolor the water. It can be all sorts of different colors. Maybe you've heard of these things: brown tides, rest tides, red tides. And in some cases, these algae are a serious human health threat because they'll make toxins that can get into the water, can get into shellfish, and be a threat to both human health and even the health of our pets. And then there's a whole second class of these types of harmful algae that we call ecosystem disruptive. Now, in good news, these are not harmful to humans, but they do lead to, as I mentioned, ecosystem harm by being lethal to different species of shellfish and finfish. And the link to nitrogen in these events is very clear. The research has all been done. And what it showed is that the more nitrogen you put into the water, some cases that results in the events getting more intense. In other cases, it results in the events getting more toxic. And as I'll explain probably a few times, many of the toxic compounds that are made by these algae are rich in nitrogen. So when they're given more nitrogen, they can become more toxic. To give some brief examples of all this, I'm actually going to start with some freshwater examples. So here's a lake on the South Shore of Long Island. So to orient you, here's the Atlantic Ocean, and here's a beautiful white sand Hamptons Beach. And here is a lake that I would imagine most people would not want to swim in. This is Lake Agawam, right in the village of Southampton, experiencing a blue-green algae bloom. And it is green because it has the overgrowth of this microscopic organism known as microcystis. And we worry about this organism because it makes the compound microcystin. When this compound was first identified in the late 20th century, scientists didn't have the name microcystin, but rather instead they very rapidly called it fast death factor because of its ability to elicit mortality in small mammals. And it's also been linked to being carcinogenic in humans. And you know a compound is strong when it can have a large effect on even larger mammals. And so if you followed the news last summer, there was ongoing reports of the mortality of large elephants across the plains of Africa, specifically in Botswana. And it was a mystery for actually several months as to why these elephants were dying. And of course, we worry about this. We worry about biodiversity on planet Earth, but we specifically worry about endangered animals like these elephants. 330 of them died, and in the end, it was linked to the occurrence of these same blue-green algae blooms. And again, you know a toxin is serious and potent when it can take down a large animal like an elephant. And that's why the US EPA has set stringent guidelines on the permissible levels of different cyanobacterial blue-green algal toxins in drinking water for children. And it's also why they have standards for recreational water, because people can be exposed just by swimming in the water. And beyond the threat to humans, we also know these events can be harmful to our pets. This report by the CDC issued some years ago identified hundreds of cases of dogs being poisoned by these blue-green algae. And on Long Island, we've actually had about less than a decade ago, a dog died in East Hampton drinking water from a blue-green algal contaminated pond. And nearly every year, there's some report of a dog getting sick putatively because of exposure to these blue-green algal toxins. And that's why the New York State Department of Environmental Conservation very carefully tracks these blue-green algae blooms. You can go to their website and see when they're happening and where they're happening. But the trend with regards to these blooms is very concerning because every year we're finding more and more water bodies across New York State that are prone to these events, to the point whereby as of last year, we were approaching 500 water bodies that have experienced these blooms. And you can see they're very widespread, more prevalent in downstate New York than far upstate New York. But this monitoring program the state has is very comprehensive. It's ongoing in all 62 counties in New York State. And of those 62, 50 counties have reported blue-green algae blooms, but actually none has had as many as Suffolk County. And that's what's shown here in 2020 with more than 24 water bodies experiencing blue-green algae blooms. And that's more than twice the even closest counties, places like Putnam and Westchester. And these blooms can be very large and pervasive. I showed you a smaller lake before, but here's Lake Erie that also borders New York State. So these blooms can get very large. And traditionally, people have considered the role of phosphorus as a nutrient promoting these blooms. But more recently, scientists from around the globe, including myself, have gotten together and considered the very important role that nitrogen plays in promoting these events. There's different types of cyanobacteria. We also call them blue-green algae. But the ones that make this toxin, microcystin, rely on nitrogen, and you can see partly why here. This toxin that I already mentioned a few times now has 10 atoms of nitrogen in it. So you don't need to be a chemist to understand the link between nitrogen and the toxicity of this organism. The more nitrogen it gets, the more toxin it's able to make. So that's just an example in freshwater. To move to our marine water bodies, here's another example of some water you would not want to swim in. And we'd like to think this is a picture from somewhere very far away, but this is an image from Great South Bay from just, I believe, the end of last summer. And certainly this is not water you would want to swim in or even be near. The red coloration is actually due to what you're seeing, this seaweed here, the decay of this seaweed. And not only does it look bad, but there's other things lurking beneath the water and other facts about this that make it very disturbing. One of the biggest of which is that this is not an native organism to New York or Long Island. This is an invasive species. This seaweed is known as Daisy siphona japonica. Japonica refers to the country, the nation Japan, and that's because this seaweed is actually native to the Pacific Ocean and native to the Southeast Asian region. However, during the end of the 20th century, it was exported to and colonized regions of Europe. And you can see here from 1988 through the end of the 20th century, reported as far north as Scandinavia and the North Sea, and also as far south as the Mediterranean Sea. And then just about a dozen years ago, it was first reported in the US. There's been a couple of reports there, but none in New York until just recently. And so what my lab did over the last few years was survey Long Island, specifically across the South Shore, to demonstrate that this invasive species is present actually throughout the South Shore of Long Island and all of the estuaries, Great South Bay, Moriches Bay, Quantuck Bay, Shinnecock Bay, and even into the Peconic Estuary. And you saw what it can look like when it's washing up and decaying. Here's more of it washing up on shorelines, making beaches look, well, not the type of beach you'd want to spend a lovely afternoon on. And the problem is that after even a short period of time, these seaweeds, when they're washed up on shore like this, begin to rot and decay and emit sulfitic fumes. And while that just sounds like a simple nuisance, there's been recent medical evidence that the decay of seaweeds can actually be a human health threat. And so this is a journal article from the journal, The Lancet, that gave multiple lines of evidence, medical evidence, that decaying seaweeds emit hydrogen sulfide, and that hydrogen sulfide can lead to things like hypoxic pulmonary, neurological, and cardiovascular lesions, and have led to, in some cases, 10,000 emergency room visits in just multiple months in a single year in the country of Martinique. And you can see what the coastline looked like there. Not actually too different than what some of the pictures that I've already shown. Beyond the effects on human health, this is also a potential threat to marine life. We've done experiments with small fish, and what those have shown is that when the seaweed is living, it's not really too bothersome for the fish. This is the survival rates over a 1 week period, and not a significant change, nothing unexpected for a larval fish. But when you get that situation where the seaweeds are decaying, you can see those fish are not going to survive very long. In fact, we get close to 100% mortality in just a week. And that's despite the fact that we're making every effort to keep them alive, putting in extra oxygen, checking the levels of ammonia. So there's actually some compound that's being released by the seaweed that's dangerous for the fish. We see a similar effect to the early life stages of hard clams, we call the larval stage. When we did the same exact experiment, we take those early life stages of the clams, expose them to just clean water, expose them to the living seaweed or that decaying seaweed, that reddish water. And you can see, again, very significant mortality, decreased survival in these larval clams compared to the ideal conditions. So this is all quite troubling. And the question is, well, why is it here? And we just published a paper on this. You can find this paper in the journal Biological Invasions, and that was, it's free to everybody on the web if you wanted to find that, not anyone. But what we looked at is the potential role of both nitrogen, nutrients, and carbon dioxide in promoting these events. So we set up a series of experiments over a 1 year period, doing experiments once a month over multiple temperature ranges that are associated with each month. And you can see you get a modest growth rate when you don't add anything, but when you give the seaweed more nutrients, more nitrogen, or more carbon dioxide, or both, the growth rates continue to increase to the point where you give them both more carbon dioxide and more nitrogen, and you can more than double their growth rate. And when we looked at the seaweeds, remember I showed you that survey where we were finding them, when we looked at the seaweeds, what we actually discovered is a clue as to what the specific nutrient is that is driving this invasion of this seaweed. don't have time to go into the scientific details of what this data shows, but I'll just essentially tell you we use something called nitrogen isotope tracing for these seaweeds. And in the end, it gives you a number that's going to range from about -3 to somewhere around 10 to 12 is a maximum. The number that you get is reflective of the type of nitrogen that the seaweeds are using. If they were growing using exclusively fertilizer-based nitrogen, they would give you a signal of -3. If you find out that they instead have a signal close to 10, that would mean they're using wastewater. And so when we look at this scale, the answer we get is that these seaweeds are using mainly wastewater in almost every single case. And by percentages, they're using, it's anywhere from 100 to 80% of their nitrogen is coming specifically from wastewater. Consistent with what I told you before, that's the main source of nitrogen to our coastal waters. Moving away from these harmful algal blooms for a moment, in the last 7 years or so, my laboratory has collaborated with News 12 to provide water quality reports for Long Island, where once a week, starting this month actually, we check 30 sites across Long Island and give each site a rating from good to poor. And this is not based on any judgment, but rather it's all quantitative. So we're using state and federal standards and finding out how does each water body measure up to those standards. And those were reported out on the during the weather forecast on News 12. And there's my friend Bill Corbell giving both after the weather forecast, giving you the water quality forecast. Now, of all that work that was done, probably the most useful data that we've been collecting for all this is the levels of oxygen that we're measuring in all these sites. And we're measuring this oxygen 24 hours a day using oxygen probes. And what that has shown, well, just one quick word on oxygen. There's a link between oxygen and algal blooms in that when you have the discharge of that nitrogen from surface, from homes into surface waters, and that stimulates these algal blooms, eventually they break down. And when the algal blooms break down, that removes oxygen from the water. And that can be dangerous to marine life. And that's why the New York State Department of Environmental Conservation has very strict standards for oxygen in surface waters. In fact, it's really the only water quality standard that exists in New York State. And the standards are that they really never want to see oxygen levels below 3 milligrams per liter, and ideally would like them above 4.8 milligrams per liter, because that's what you need to support healthy marine life. But when looking at the levels across the 30 some sites that we sample and monitor over time, what we find is many of these systems are not measuring up even to the lowest standard. That is, more than half of the sites fail the acute dissolved oxygen standard at some point in time. And the other sites, some of them make the intermediate standard, and then there are some that are actually can always have the best levels of oxygen. But when you get into this danger zone, you're set up for a situation that's dangerous to marine life. I already told you that. All life outside of bacteria need oxygen to persist. And so when you have those low oxygen conditions and you get a school of fish swimming in there, you can have incidents such as these, widespread occurrences of fish kills. This is on the east end, both in Riverhead, Shinnecock Canal. And then last summer, we saw similar things, somewhat smaller fish. These are known as peanut bunker, but still these are very important bait fish that support fisheries. And when the fish run into those low oxygen conditions, well, you can see what the outcome is. And again, all of these things are linked back to nitrogen. So, thus far, I've really emphasized the very local nature of everything that's going on in our surface waters. But I'm going to transition now for a moment to talk about something known as the Anthropocene. And so, scientists are now using this term, Anthropocene, to define the geological era we are in today. So we all have heard and seen the movie, for example, Jurassic Park, Jurassic referring to a former geological age. Scientists now believe, and there's a consensus, that we're now in what we call the Anthropocene. And that's the era where the activities of humans are now the dominant influence on our climate and on the environment, and that these influences are overwhelming the forces of nature. And what's important to note is that as we look at things, as we consider this, when we think about our local ecosystems, as I've already shown you what's going on there, we really need to consider that we are in the Anthropocene and all of the processes that go on along with that. And so, for example, we need to think about global temperatures. And so here's a map put out by NOAA at the end of last year showing the temperatures on average for 2020. And essentially what it shows is that a lot of planet Earth set a record for temperatures in 2020. And I don't have the time to get into it, but the fact that that occurred, well, we had high temperatures everywhere. And I'll note this big white area here. This is an event, an oceanographic event we called La Nina, that was like an air conditioner for planet Earth. But despite the fact that we had a La Nina event that kept things actually in this very large part of the Pacific Ocean, much cooler than usual, we set a new record for temperatures in 2020. And so that was really surprising because the last record was during the reverse event. We had something known as El Nino in the Pacific Ocean that is like turning off the air conditioner. We had La Nina last year, we were turning up the air conditioner, and yet we still set a new record for temperatures. While temperatures go up, a simple consequence that I'll probably refer to later is that the oxygen levels in the ocean go down. And I've already told you how important oxygen is for marine life. And of course, all of these changes are being driven by changes in the levels of CO2 in our atmosphere. And that has effects on coastal ecosystems, a process known as ocean acidification. And that is as the CO2 levels go up, the pH levels go down. And what's remarkable about carbon dioxide readings is they just keep going up. And if you followed the news this week, you would have learned that we set a brand new record for CO2. This is March. As of this week, the new record for carbon dioxide in the atmosphere is set at 420 parts per million. And you can see that, just not long ago when we began making these readings, we were below 320 parts per million. So that's a significant change in a very short period of time.
Chris, unmute. There you go.
Yeah, sorry about that. I just let somebody in and incidentally, I guess, hit the mute button. When we think about all these global climate change factors, then now we can pivot back to see how that's affecting things locally. Because one of the important tenets of climate change, when I say we set a record for global temperatures, well, that's for all of planet Earth. But the fact of the matter is that temperature changes differ by location, by latitude, by continent, by ocean, and also by season. So all of these things are changing. So when we look at temperature changes here around Long Island and around New York, the fact of the matter is our temperatures in the winter and spring really haven't changed too drastically. However, when we look at what's been going on during the summer, particularly in our coastal waters, the changes are very measurable and notable. So these are satellite-based temperature records. In 1982, NOAA began launching satellites that gave records of temperature. Of course, the amazing thing about satellites is they can cover the entire planet in just 48 hours. So as a consequence, there is actually now a data set where you can figure out what the temperatures were for just about every square quarter degree of planet Earth, going all the way back to 1982, any day of the year. And so with collaborators, I've been able to access this database. And so you can see here during the months of July, August, and September, how the coastal waters around Long Island, this is both in Long Island Sound and also on the South Shore, have been increasing over time. And when we get even further inland and look at some of the individual bays and estuaries, we need even finer satellites. And those were first launched by NASA at the beginning of the current century. And when we look at those records, the the changes are also dramatic there as well. So here is just 17 years of temperature records. And what it shows is a statistically significant increase in summer, specifically the month of July temperatures in Great Peconic Bay. And when we look on the North Shore, Long Island Sound, we see both summer temperatures and fall temperatures have been significantly increasing. And again, this is just the last 17 years. And then we're looking at more than a degree of temperature change, in some cases 2 degrees. You look at the summer temperature change in that very short period of time. And of course, as a scientist, it's the summer change in temperatures that I'm actually the most worried about. Because what that means is our waters are hitting temperatures they've never seen before, right? If this was in the spring or in the fall, where you could say, oh, things are just accelerating, right? We're heading towards summer faster, the summer's extending into fall. But when it's the summer that's hitting new record temperatures, what that means is that everything is exposed to something that's brand new. As I sort of mentioned before, but I want to emphasize once more, when temperatures go up via the laws of physics and the ideal gas law, dissolved oxygen levels go down. And I've already emphasized to you how important oxygen is for marine life. And so now what I'd like to do is give you an example of how all of these factors can interact to affect our fisheries. And so to do that, I want to toggle back momentarily to talk about a different harmful algal bloom we haven't covered, something known as rust tide. And you can see how it gets its name here. This is, I believe, Flanders Bay on the Peconic Estuary that normally has this sort of pale green color. So you know when one of these events has shown up. We never saw these events before 2004. They've now become annual occurrences on the east end. Are now showing up on the North Shore as well. We worry about these events because they're what's known as ichthyotoxic, which means they are fish killing. We've learned that the hard way at our marine lab in Southampton. We've had water come in, wash over some of the fish there and lead to mass mortalities. We've also, and just giving you some close-ups of what these events can look like, we've also seen mortality of shellfish and oysters and scallops as well. So why are we having these events? Well, one thing we know is that this species responds to nitrogen in a positive way more frequently than other types of algae that are out there. But it's not just a nitrogen story. We've also looked at how temperature affects this organism. And so what you're looking at here is a model we had put together that considers how long this organism can form a bloom in our coastal waters and how that's changed since 1982. So the scale here is how many days per year the bloom season for this rust tide had increased from 1982 to 2017. And the bottom line is the answer to that question is very site specific. So if you're down, say, off the coast of Carolina, that bloom season is actually shortening for this organism. But for us, we're in the bullseye. And in fact, the bloom season had gone from being almost no days per year, but by getting an increase of almost 2 days per year over this time period, we have a bloom season that's now multiple months and will start any day now and go all the way into September. And so what I'd like to now do is take all this information and put it together. So when you have rising temperatures along with rising levels of nitrogen, I just showed you, that's going to give you one of these rust tide events. But of course, it's not just that it makes the water look bad. We know that they're dangerous to shellfish like scallops. And in addition, we also know that when it gets really warm, the scallops aren't happy. And even further, we know that when it gets really warm, the oxygen levels go down. And that's also not good for scallops. And therefore, perhaps it's not a surprise that the bay scallop fishery on the East End has literally collapsed during the last 2 years. As we're getting to warmer temperatures, more rust tide. I don't have time today to talk about the role of ocean acidification, but there's a role there. And I also don't have time to talk about parasites, but there is a parasite that's been present in these organisms as well. So thus far, I've showed you that we've got all these stressors on coastal ecosystems intensifying. We've got fisheries retreating. And when we think about things like the rise in carbon dioxide and changes in global temperatures, you know, on a global base, these are global phenomena. And, you know, just being perfectly honest, I will just say two words that will convey the idea that we alone can't change the course of climate change. And those two words are China and India, because those are the two countries that are the biggest contributors to levels of CO2 in the atmosphere. And they're far behind Europe and North America in mitigating climate change. And, you know, and frankly, we haven't even done enough here in the United States to mitigate that. But I bring this up not as a means for saying nothing that can be done, but rather bring it up to make a very important point. And that is, if there is specific action we want to take now in order to improve conditions, it is likely that it's the mitigation of nitrogen from land to sea that is our most promising tool to bring about the types of change we need. And it literally is, you know, it's not, I won't call it the only tool in the toolbox. There's multiple ways to do that, but it is our most valuable approach. And to pivot from all sorts of potentially bad news, what I'd like to emphasize now is that we're on the right track for addressing this nitrogen issue. For example, just last year, Suffolk County passed its sub-watersheds plan. This is an incredibly scientifically robust plan, probably one of the most scientifically and data informed management plans that exist in the country. And I have the term here, from worst to first. Now I added that here, that's not on their report. And that's my term because essentially what it does is it transforms Suffolk County to a position where 7 or 8 years ago, we might have been the worst county in the country for dealing with wastewater. I'll explain why. We already know why, because we were discharging our wastewater directly to our aquifer without treating it whatsoever. But with this plan, and this very aggressive plan, I would argue there is not a county in the nation that has a more forward-looking plan for addressing on-site wastewater than Suffolk County. And so, for example, that plan looked at literally divided up Suffolk County into more than 220 individual what we call sub-watersheds, and hence the term sub-watersheds plan, and then prioritized each of these sub-watersheds for upgrading septic systems based on potential threats to people's health via drinking water and potential threats to coastal ecosystems via the strength of the nitrogen that was discharging into surface waters. And like I said, it's very forward thinking. So phase 2 of this plan goes all the way to the year 2050. And by that time, the plan has over 218,000 septic systems being upgraded. And the effect this plan is going to have is remarkable. So what you're looking at here are two versions of Long Island or Suffolk County. The one in the upper left is if we do nothing. And what I can tell you is that any area that is orange or red are levels of nitrogen that are extremely high and will have a strong effect on coastal ecosystems. And I don't even have time to get into it today, but it's even a human health threat. By contrast, with the implementation of this plan, you can see we get rid of and do away with nearly all of the red and orange zones and have a lot more of those cooler colors, the low nitrogen levels that will be more protective of our coastal ecosystems and more protective of public health. I've emphasized a lot of Suffolk County so far. I do want to mention that I authored a study for the New York State Department of Environmental Conservation that was also published last year on Nassau County. Now, Nassau County is really a tale of two different shorelines, the North Shore and the South Shore. The South Shore of Nassau County is almost entirely sewered, and that wastewater is discharged out into either the ocean or into coastal waters. But the North Shore of Nassau County looks remarkably similar to Suffolk County, in that we've got all these on-site septic systems that represent the majority of nitrogen going from land to sea. followed next by fertilizer. And so when we take the number of systems that are in Nassau County and Suffolk County, we've got almost 500,000 that are not connected to sewage treatment plants, but rather instead are discharging to groundwater. And the question is, what will we do about this? Now, I will just offer for a moment that in speaking to officials in both Nassau and Suffolk County, I can tell you that sewering Long Island is no longer an option. It costs tens of millions of dollars to build a sewage treatment plant, and then costs upwards of $50,000 to $100,000 per home to hook up a home to a sewer line. So instead, the solution are individual on-site septic systems that aren't just a hole in the ground, but actually remove contaminants, remove nitrogen from the wastewater. You can see here there are now 5, actually now there's even a 6th, systems that have been approved by Suffolk County to be installed in homes. Now at the university, beyond being a professor in the School of Marine and Atmospheric Sciences, another hat that I wear is I am the director of New York State's Center for Clean Water Technology. And our center has a mission statement of harnessing science to engineer clean water for the protection of public health and the environment in New York and beyond. And when it comes to wastewater, we have a goal we call 10, 20, 30. And that is, we want septic systems, advanced septic systems, that will reduce nitrogen levels to down below 10 milligrams per liter, that will cost less than $20,000 per home, which is what the would make it the most price competitive on the market, and will last for at least 30 years. And I'm happy to say that we've achieved these goals by designing something we call nitrogen removing biofilters. These systems are fairly simplistic, and they're meant to be attached to existing septic systems, and they're near passive systems. All they have are a single pump, so much simpler than the systems shown here that have aerators and multiple chambers, etc. And they also operate on very, very simplistic terms in that they are essentially what are known as drain fields, which is what's used to dispose wastewater in many parts of the nation, that are underlain by a layer of sand, and a layer of sand that's mixed with wood chips. And that those wood chips are a source of carbon that promote this magical process called denitrification to get the nitrogen out of the wastewater. And so we have a few different versions of these systems, one in which the bottom layer is lined, and that allows for maximal performance, but is a little bit more difficult to install. We have unlined systems that simply drain to groundwater after being treated by the layers of sand and sand mixed with wood chips. And we have our wood chip box systems, where we have the sand layer isolated from the wood chip tank. And that allows for that tank to be inspected and potentially replaced with new wood chips over time. And so just earlier this year, we published a paper on the performance of these systems. And if you'd like to read about that, this journal article is available for free online. And the title is really says it all, and that these systems remove 80 to 90% of nitrogen and also organic contaminants. And so just showing some of the data from there. Here, what I'm showing you is our 3 different types of systems. We call them NRBs for nitrogen removing biofilters. And the data here are from homes, installing these at different homes across Suffolk County. And the influent is the nitrogen coming out of the home, and the effluent is the nitrogen coming out of our systems. And I have 2 lines in here. The red line is Suffolk County's regulation. They want to see nitrogen effluent of less than 19 milligrams per liter. And the blue line is our standard. I told you we have a higher standard for ourselves. We want to get the levels even lower, down below 10 milligrams per liter. Beyond nitrogen, we've also done research to show that these systems also remove 90% of phosphorus or better, and also 98% or better of pathogens. And beyond all of these contaminants, there's been a lot of concern in recent years with regards to other sorts of contaminants, things like drugs, pharmaceuticals, and personal care products. And of course, it would take a very long time to go through this full data set. But what you're looking at here are more than 24 of such compounds and the percent removal rates we get with our NRBs. And you can see in some cases we're getting 100% removal, always better than 50% removal. And also in all cases, the removal rates we're getting for these compounds are significantly better than what you get from a sewage treatment plant. And again, these are things we do not want getting into our drinking water supply. In addition to all of these personal care products, another contaminant in many water supplies on Long Island is known as 1,4-dioxane. The EPA defines 1,4-dioxane as a probable carcinogen and the highest level ever reported in a drinking water supply in the world has been reported on Long Island, I think specifically in Hicksville. This is something that's of a great concern, of course. And you can see this paper also just published earlier this year about our nitrogen removing biofilters also shows that we can remove 1,4-dioxane from wastewater, which is really remarkable in that to remove this from a regular drinking water supply, you need some very advanced processes. You cannot remove it via filtration. You cannot remove it via carbon filters. But in our study, we firstly found that actually homes themselves are a significant source of 1,4-dioxane as well, as it's being added to detergents and some personal care products. But our systems are reducing the levels of 1,4-dioxane by more than 60% and always getting it down below the state standard for 1,4-dioxane in drinking water, which is 1 microgram per liter. So we're excited about the performance of these nitrogen removing biofilters. They're currently in what is known as the piloting phase of testing in Suffolk County. So we are eager to see these be provisionally approved. We expect that to happen by next summer for our unlined systems, and we think our other systems will also be approved by Suffolk County in 2022 or 2023. So beyond dealing with septic systems, there are other approaches that we're also involved in to try to deal with nitrogen actually after it gets in the water. Because here's the fact of the matter. I showed you that Subwatersheds plan has a decadal vision, and that is by 2050, we hope to have the majority of homes in Suffolk County upgraded. That's a long ways off. And in addition, it can take decades for water to flow from land out to sea and actually to purge the high nitrogen that's already in the water table. And so we also need approaches today to deal with high nitrogen. Now, one way of doing that is with bivalves, clams, and other shellfish. Now, in the interest of time, I really don't have the time to go through all of this. But what I can tell you is that if you go to my lab's YouTube channel and look up Shinnecock Bay Restoration Program, you can see a seminar that I gave last month that explains the work that we're doing in Shinnecock Bay, where we've planted millions of clams, the water is getting cleaner, and the number of clams that people are able to harvest because of the offspring these clams are creating has increased literally 1,000% in the last decade. But in the interest of time, I'm going to focus on something slightly different, and that is seaweeds, and specifically a seaweed known as kelp. This seaweed, and I'll mention that this effort is largely led by my friend and colleague, Michael Dole, who is the Associate Director for Aquaculture Initiatives within my laboratory. We also work with a company known as Greenwave from Connecticut. And so kelp is a seaweed, and why would we think about kelp? Well, actually, we're a little late to the game in New York when it comes to kelp. People have been farming kelp in places like Maine for years. It's an indigenous seaweed, so we're not introducing anything strange. And in places where they do grow kelp, they do something they call 3D bivalve farming. And that is, people are already aquaculturing different bivalves like oysters can do so on the surface or on the bottom. And the same lines that they put out for growing their oysters, they can attach kelp to those lines and see that kelp grow vertically. And importantly, the kelp is actually what's known as a cold water species. You can see Mike here with his hat on. And the idea being that when we put the kelp lines out in the winter, we actually put them out in December, you can't see any kelp on there. They're just literally microscopic little blades. But over the winter, and particularly in the spring, they begin to grow dense and long and thick. And during the past several years, we've grown kelp on 10 different oyster farms across Long Island, from the South Shore to the North Shore, through the Peconic Estuary, and even out on Fisher's Island. And that kelp grows very rapidly. And again, this gives you a sense of the timing. We usually put it out in December. This is data from last year. And again, you barely can see it on the lines, but then just as spring starts to arrive, it really takes off. And what you're seeing here is the weight of the kelp per 1 foot of line. So you can see we're getting towards, in some cases, 9 or 10 feet, and we're putting out 100-foot lines, and we're putting out multiple 100-foot lines per farm. With the upshot being, it's not hard for us to get 1,000 pounds of kelp in a single season. And here is Mike showing you how long those kelp blades can grow. The remarkable thing is, here it is, a 12-foot line, a 12-foot blade of kelp. And what's even more remarkable is that we achieved this in actually shallow water. This is just only in a few feet of water. And the fact of the matter is also that before we started this study, people thought you needed to have 12 feet of water to get a 12-foot kelp line, but we've shown that's not the case. But more importantly, beyond just growing this and what it can do, this can be a food product, I should say. People are interested in actually using this for food. We've done some research on using it as a fertilizer. It can be a food additive. But probably what I'm most interested in is how the kelp can modify what's happening in the seawater. As a photosynthetic organism, it takes up carbon dioxide. And right there, you're battling climate change, at least locally. And also, as it grows, takes nitrogen out of the water, and which I've already emphasized how important that is. And it produces oxygen, I told you, which can be in short supply. And it might even be able to combat harmful algal blooms. So just to quickly show some data here, here are 3 different locations, just showing how much nitrogen the organism can take up. And the fact of the matter is, the systems with the highest levels of nitrogen end up that the kelp take up the most nitrogen there. And if we calculate that nitrogen out, what we figured is that a single kelp farm can yield hundreds of pounds of nitrogen in a single year, which is the equivalent of upgrading multiple homes and their septic systems. And again, this is not to say that we should do this instead of upgrading septic systems, but it is to say that while the homes are being upgraded, we can also do work in the water to combat nitrogen. And as it turns out, this kelp can also fight one of the most dangerous harmful algal blooms, known as Alexandria. Talked about harmful algal blooms many times, and I'll just simply mention that this particular one makes this compound known as saxitoxin. This is a neurotoxin that is 1,000 times stronger than cyanide. And it can get into shellfish and be dangerous. Very sadly, a man died last summer in Alaska from eating shellfish that were contaminated with that saxitoxin. This organism is widespread across Long Island, and there's been more than 7 locations on Long Island where the shellfish beds have been closed to shellfishing because of saxitoxin and the potential for paralytic shellfish poisoning. Turns out, however, this little organism that looks like this and causes these events does not like kelp. When you expose it to kelp, the cells transform from this rich dark color, that's all their pigments they have, to this, where they're literally, if you look very carefully what's happening here, the cells are literally spilling their guts. They do not like the kelp. There's a compound that kelp's releasing. We've done experiments where we get water during a harmful algal bloom. We leave that water unamended or amend it with nutrients, or add kelp, and you can see by adding the kelp, we can reduce the densities of this harmful algal bloom by several fold. We even did the experiment where you expose mussels to the organism that makes this toxin with and without exposing the kelp. And what we found is if you expose the mussels if the mussels are grown with the kelp, it significantly reduces the amount of toxin that they have in their shellfish, so much so that it gets them down below what we call the FDA closure limit. Not we call, that's what it is, the FDA closure limit. And so, you know, these seaweeds, this kelp, is not necessarily going to fight climate change globally, but we think can create this halo effect on oyster farms where the kelp can be there, providing oxygen, taking out CO2, taking up nitrogen, and protecting the shellfish from these harmful algal blooms. Now, I've mentioned that the seaweeds can be used as a food product. One last consideration for what we do with those seaweeds is to use them as a fertilizer. And of course, fertilizer in and of itself is a problem for our coastal ecosystems. It can actually cause the overgrowth of seaweeds. But what if we could make the seaweeds the actual fertilizer? And we've actually done just that in our labs at Stony Brook. So just to end things here, let's play a trivia game, or just a game in general. I have a graph here, and what it's showing is the levels of nitrogen and phosphorus in 3 different types of fertilizer. And you can see the lines. So divide up, here's fertilizer number 1, fertilizer number 2, fertilizer number 3. They've not been labeled. One of these is Miracle-Gro. The other 2 are seaweed-based fertilizers. So you now can all individually guess which is which. And here's the answer. This is the Miracle-Gro. So this is a fertilizer we're able to make a liquid out of just kelp. And here's one using seaweeds that grow actually in the summer. And you can see even more enriched in nitrogen and phosphorus than even Miracle-Gro. And beyond the chemical content, picture's worth 1,000 words. There is my son, John and Pat's grandson, Luke, holding eggplants that were grown with the seaweed fertilizer and with no fertilizer. And you can see the differences here, that is numerically with regards to the weight of the eggplants. We've also gotten great results with bell peppers and other vegetables and flowering plants. So I am done. I'll just conclude with some quick remarks and conclusions. I've shown you that excessive nitrogen loading from wastewater is a threat to coastal ecosystems, economies, pets, and even human health. And I've showed you that climate change is accelerating and starting to affect marine ecosystems in a quite obvious way. I've explained how upgrading septic systems is probably our primary approach for reversing water quality impairment and removing contaminants from our drinking water supply. And that kelp holds the promise to mitigate water quality and improve water quality on a localized level and is also a potent fertilizer. So with that, I will thank you kindly for your attention, and I would be very happy to answer any questions.
Thank you, Chris. That was amazing. Really good information. We do have a question here from Maureen. She asked if you're familiar with the proposed gyrodyne development, including a sewage treatment plant, and does your Center for Clean Water Technology have any input on the dispute between Brookhaven and Smithtown? And do you have an opinion on that?
Yeah, so I'm familiar with the development in broad terms, but I'm not familiar with the details. The fact that they would have a sewage treatment plant is a good thing, but the fact that, but you know, the devil's in the details there, and that is where's that wastewater, where would that plant be discharging to, and you know, what sub watershed is that part of? And I will say I presently don't have enough information to have a well-informed opinion. But except outside of, like I would say, the very important that whatever is done there, the wastewater is treated to the highest degree possible.
The question I asked was, are the sewer systems removing the 1,4-dioxane?
They do, but very little, significantly less than the systems we've designed. And honestly, that was an accident. We didn't design these systems to remove these sort of contaminants, but as it turns out, the reason that our systems work so well for these contaminants is that sand layer. In the sand layer, there's enough oxygen for the types of bacteria that can break down these compounds, and the water takes longer time to go through our systems than it does a sewage treatment plant and some other systems. So that combines to lead to that high level of removal.
So is there any resolution similar to what you're proposing with these septic systems for sewer treatment plants and for people that have sewers and not septic systems?
Yeah, so it's possible, we have been talking about this, well, I guess there's two things I'd say. One, it's possible that that sand layer of treatment could be incorporated into a sewage treatment plant, although it would need to be very large. So that may or may not be feasible. And then the other approach is that's on what we could call the front end. The other thing we've done in the Center for Clean Water Technologies, we also focus on drinking water. And we have discovered, working with Suffolk County Water Authority and other water purveyors on Long Island, that there is a process called advanced oxidation processes that can be used to remove 1,4-dioxane from our drinking water supply in a safe way. So if we don't get it in the front end, we do now have the means to install basically what these are UV treatment systems coupled with hydrogen peroxide. And we did a pilot study with Suffolk County Water Authority to demonstrate that can be effective. And importantly, not just at removing it, but not creating other things we don't want in our water supply.
All right, thank you. I don't see any other questions. Does anybody want to raise their hand? Does anybody else have any questions that they want to ask? If you want to just raise your virtual hand or your real hand. I'm happy to answer any questions you have. Anyone? Well, I have a question because I'm very interested in what you're saying. What do you think of the Suffolk County water system and drinking from the faucet? Is it safe?
Yeah, so that's a great question. And so what I would say is that if your water comes from Suffolk County Water Authority, you're very fortunate because they actually have some of the best testing facilities in the country, and also are very vigilant about their standards. So essentially what they do is if there's a standard, for example, of 1 part per billion for 1,4-dioxane, which there is now, once their water levels get to a 0.5 part per billion, they will institute treatment to remove it. So we are fortunate, and in many cases the water quality is excellent, particularly for any regulated contaminants. The only caveat, well, the caveats I would give is one, not everybody has water from Suffolk County Water Authority. Most people do in Suffolk County, but on the East End, for example, there are, I believe, more than 100,000 people who have private wells. And there are a few other water purveyors in Suffolk County and many in Nassau County that are not as comprehensive in their testing as Suffolk County Water Authority.
How do you compare that to the spring water upstate that I've always heard is wonderful?
Yeah, I mean, for example, New York City has a great water supply from reservoirs that come in. So, and again, with very careful testing. The only other thing that comes to mind as I give that answer is that there's always both emerging research and what we call emerging contaminants, and so that's always something to keep in mind.
Good. We might have a question in the chat. Oh no, thanks for the research you're doing in our Long Island area. Excellent presentation. That's what people are saying. Any other questions for Chris?
I do see one in the chat that came up about any special brand of seaweed kelp fertilizer you could suggest. And so that's a good question. And I'd say stay tuned. We're hopeful that what we're seeking to do is to have our own brand here that we'll have publicly available in the future. And there's interest in doing this. There's both from multiple angles, because people who want to promote seaweeds as a industry recognize that to have that happen, there needs to be multiple markets for the seaweeds. Like I said, there's the food market, and people are very interested in that. There's actually a natural products market, so it can be used for as a food additive. And then we're hopeful there'll be a fertilizer market as well. So for a kelp fertilizer, I say hold out for the Long Island brand that will be forthcoming.
So if it's for consumption, and it's removing these contaminants and pathogens or what have you, is it okay to eat?
No, it's not. The one example I gave is that it kills off harmful algal blooms, but that's sort of a totally out. That's because of what it releases into the water to kill off the microbes. But I will also say that there is a plan there is vigorous testing, for any food product. Any food product that gets consumed by the public has to go meet the standards of the FDA for both chemical contaminants, microbial contaminants, and all.
Yeah. Wow, this is great. Any other questions, anybody? I mean, Chris, I could keep you here for an hour. But I'm very, pro-green and eco-friendly myself. But this is great work you're doing. We really appreciate you coming. We hope you'll come back again because I'm sure you're going to have more updated information, but it's really hopeful information for Long Island because I know a lot of people, we're a little worried about our water systems.
Sure.
Over the past number of years. Thank you. Thank you again.
Okay.